Okay, the first hard question from chapter 2. The question is right here. So the idea is that we have two species of bear, of panda bear, and that we can't tell them apart in any way except for one thing. And that is that species A gives birth to twins 10% of the time, and species B gives birth to twins 20% of the time. And we're supposed to take these numbers as being reasonably certain, or so don't quibble with the research that went into this, I guess. So then we're asked to find the probability of, well, first we make the observation that one of these pandas has had a set of twins, and we want to know what is the probability that the next birthing that this panda has will also be twins. Okay, and again, all that we really have to go on is the information about how the two species differ. Okay. So if you've been watching through the card videos, the 2M4 to 2M7 or so, you'll notice some parallels here. Whereas in the card videos, we were looking for, we turned a card over that had two sides, and we saw a black face up, and the other side might be black or white. And we used information given in the problem to try to decide what the other side of that card was, or what color the other side of that card was. And so we have something similar going on here, but now we're trying to find the probability that the second birthing will be twins, given that we saw that this first birthing was twins. Okay, and so we'll use this kind of notation here: twins 2, twins 1 instead. The approach that we've been taking in all of these videos is to try to find values for these terms in Bayes' theorem. This is one way to write Bayes' theorem, but roughly it has been in the numerator here, the probability, or this would be the likelihood, okay, and in this case, probability that the first set of twins, or that the first birthing was twins, given that the second birthing was twins. That would be the likelihood in this problem, in this formulation of Bayes, times the prior that the second birthing would be twins, divided by the probability that the first birthing was twins. But that's a little bit hard to apply here, because if we're trying to find the probability that the second birthing is twins, given that the first one was, but one of the things we need to know is the probability that the first set of twins was, or the first birthing was twins, given that the second birthing is twins. That's just as, I don't know that any more than I know the thing that we're trying to solve for. And so it's not going to be easy to use this formula of Bayes. So instead what we'll use is a different formula for Bayes. So recognize that Bayes is a conditional probability, and the definition of conditional probability is this: it is the joint probability of events divided by the thing that you are conditioning on, divided by the marginal here. Okay, and we actually can use this. So this formula is equivalent to this formula. Okay, and so we can actually use this formula here to solve the problem. Okay, so let's start by trying to figure these out. So we're first going to figure the joint probability. This is called the joint probability when we have this event and that event. Okay, and so to do that, we need to first lay out a prior probability for the species, right? So we're assuming that both species are equally likely. Okay, it's just that if we have species A, they have twins 10% of the time. If we have species B, they have twins 20% of the time. Okay, so that means that I can find then the probability of the first set of twins being, or the first birthing being twins, and that's going to be equal to the second birthing being twins. Okay, And so all that is the probability that the species that we have at hand is species A times the probability that species A has twins. Okay, so it's the 1/2 times 10%. And then to that, I'm just adding the probability that we have species B times the probability that species B has twins. Okay, so this is our joint probability. Or I'm sorry, this is not our joint probability. This is our marginal probability. Well, now we can use a similar idea here. This is our joint right here. We can use a similar idea then to find the probability of birthing 1 and birthing 2 being twins. Okay, so we use a similar setup. So we take the species of the panda that we have, or the possibility that it's species A, times the probability of twins twice. So we square, this is square, this little caret 2 here. I'm squaring then the probability that species A has twins, right? Because I had two sets of twins, okay? And then similarly for species B, what is the probability that it's species B? It's 1/2 times the probability that species B has twins twice. Okay, so now that's our joint probability. And posterior. And so now we can find our posterior. Okay, so twins 2 given twins 1, that's what we have here. Okay, and I'm going to divide the joint probability here, twins 1 and twins 2, divided by the probability that the first birthing was twins, which is what we had here. Okay, and so if I run this, I get about 17%, or it would be 1 in 6.